Hello, everyone. I'm pleased to welcome you to our deep dive regarding vision applications with the ctrlX Core and the LumiScan Suite. I will moderate the meeting and give you a short introduction. And our special guest today is Quirinus Schwarzenböck from HD Vision System. He will provide you technical details and share with you his expert knowledge regarding vision and the LumiScan Suite. First, short general rules. The presentation is recorded, so please mute your microphone during the presentation. It will be stored in the slide will be stored in the Docupedia area, where you can find all the other trainings as usual. If you have questions, then you can put them in the chat and we try to answer them in parallel. Or to make things a little bit more interactive, you can also ask your question during the presentation and unmute yourself and speak into it. Because we have enough time, so don't hesitate to ask a question. At the end of the presentation, we have a longer Q&A session where we can again take time and go through the remaining open question. The agenda, we are now in the introduction, and then Quirinus will take over for the technical content, and at the end, a Q&A session again. I'd like to pick up where I first announced this topic. Maybe you can remember in the last update training in April, I announced that we now have a new extension module for the Core Plus. So we have now an AI module for the Core Plus X3. You can order the device. And for the Core Plus X5 and X7, it will be available soon. We are really close to the release. I think until July, it will be available. And with this new AI module, it expands the functionality of the ctrlX Core, and it enables the integration of AI directly at the edge, and so into everyday automation tasks. And what I would like to underline here is the focus on the goal of this training is it's not an application training. So at the end, we won't be able to engineer all the solution on your own. The goal of this training today is to raise your awareness of new possibilities or of new application that we can address with the solution. In the AI module, there is an Hilo 8 chip. It's AI accelerator, and it's optimized for computing AI algorithm. Yeah, so it enables fast and efficient data processing directly at the edge without the need of additional hardware. And AI is more than just vision, of course. Yeah. But today in the ctrlX automation ecosystem, we have with the LumiScan Suite from HD Vision Systems, we have a complete software solution, end-to-end software solution that covers all the different steps from data acquisition and model training up to integration in the production environment. And that's why in the first step, we focus on vision application. Okay, and now I'd like to hand over to Quirinus, and he will share with you all the details and what and how and what you have to pay attention to. So, Quirinus, stage is yours.
Hey everyone. So my name is Quirinus Schwarzenböck. I'm from HD Vision Systems. My background is I have studied physics at the University of Heidelberg and am now an application engineer and machine learning specialist at HD Vision Systems. HD Vision Systems is a company in Heidelberg and has been founded in 2017. Originally, we've been part of the university until we founded the company. And right now we are 15 experts in machine vision, kinematics, robotics, and software development. And our core product is a light field imaging sensor, the LumiScan X, which is a 3D sensor. So you can take normal 2D images, but also capture 3D data. And with this 3D data, we are able to do applications for vision-guided robotics like bin picking, bin placing, depalletization. But we are also doing quality inspection. On the one hand, visual quality inspection just on the 2D images, but also 3D quality inspection. And in collaboration with Bosch Rexroth, we have developed the LumiScan Suite and have brought some vision tools to the ctrlX ecosystem. Our vision tools, or the most basic of our vision tools, is the LumiScan Cam Driver, which allows you to connect a camera to the ctrlX. You can connect any camera supporting the GIGI Ethernet standard, and that has Ethernet to connect it to devices too. And around this image capturing tool, we have created a pipeline that allows you to run object detection AI models on these images, train them yourselves, and also convert the found pixel coordinates from these images to real-world coordinates to be able to interact with objects with robots, for example. So what you do with our pipeline is you capture images and annotate them. Image annotation means you show or you tell the image where certain objects are. We will do a deep dive on this topic later. Then you train your own model so you can detect objects on never before unseen images. So you have a general model to detect the objects you want to interact with. And then you load this model onto the ctrlX and run it with the images taken by the ctrlX. If you see that there's anything wrong with it, you can start this pipeline over again. If you're happy with the results, the PLC, for example, can access the data, the 2D data as well as the 3D data, and give you feedback for what object the model has found on the images. So the vision apps that we have developed for the ctrlX ecosystem are LumiScan Cam Driver, LumiScan AI Object Matching, and LumiScan Calibration. And these are the apps that run on the ctrlX itself. And these are the apps that will run during the normal deployment cycle or production cycle. The Cam Driver is the connection to the camera. The AI Object Matching is the container for the object detection models, and the calibration provides the calibration between 2D images and the real world. The training of these object detection models has to be on a separate EPC or industry PC. And this is really where the important stuff is happening. So we have LumiScan training framework, which is the tool we use to train our object detection models, or which is the tool you can use to train the object detection models. And we have LumiScan annotation framework, which we are seeing right here, and which is used to annotate the images. And what are we seeing here? We have a scene full of syringes, and we have annotated all the syringes that can be grabbed without any complications. So we don't want to detect any objects that are overlaid by other objects, because if you would grip them with whatever gripper you have, you'd cause all the overlying objects to fly around your production hall. What we also can see is that we detect the location of this object, but we also detect the rotation and the orientation. And with orientation, I mean that the green bar indicates the position of the plunger of these syringes. And all of this is done in one step. There's no additional processing needed once your model is trained. So you can just pick the objects and then place them with all the information you need in whatever packaging or you want to do with them. And just to visualize again, the annotation framework and training framework run on a separate IPC machine. This can be some PC that's centrally located within a production hall, or for integrator, integration partner, where he just trains all his models for his customers. And the cam driver, the object matching, and the calibration are what run on the ctrlX core, and that are part of the actual production lines. So now for a quick example of the annotation framework, because this is what's really crucial. Despite some other topics, this is one of the topics that's really crucial when developing an object detection framework, because there's just some features that you need to recognize. So what you're doing is you really just draw boxes around the objects you want to work with. You can adjust these boxes. We'll see right now, I have drawn this box the wrong way around. The green bar is not where the plunger is, so we just rotate it. Also, I've drawn the box too big, so we're making it smaller. And that's just really the basic interaction you need to do during the annotation process. Some features you need to be aware of when working with, or when annotating data, or when capturing data that you want to annotate later, is you want to mind the lighting condition. You want to have a homogeneously illuminated scene, so that there are no dark spots, light spots, and the camera can capture everything clearly. You also want to mind the resolution of the camera. On the one hand, more resolution or higher resolution means more processing time. It means that maybe we have to run inference on these images in patches and can't process all of the image at once. On the other hand, you still want to make sure that all the details, all the features you really want to make out on these images are visible. These are like the two aspects that need to balance out. And also, ideally during annotation and capturing process, you want to work with as little images as possible, because this is the step that really needs some work in this process. So usually we say a model is fine with 20 to 30 images, at least an initial model. But this is only true if the data you give to the model is really diverse. For example, the case of these syringes, it wouldn't work if you just pick out one of these syringes you're seeing, take another image, and use this also for training. There's no real variety there. What you want to do is really take your hand, mix the syringes around for once, and then take another image. Yeah. Other things you need to mind is just how you do the annotation. The object location is obviously very important, but also object dimensions, for example. I have an example here also of the syringes, and this is like the customer has annotated these images. So some of these syringes have been annotated with boxes that are just encasing the main body of these syringes. Other ones are including every part that is visible. And there's no right or wrong way. It's just really important to know that if you mix these two examples, the result will look kind of unpredictable. Sometimes you will have the case on the top, sometimes you will have the case on the bottom, and sometimes you will have some mixture of the both. And if the width of these boxes is important to you, then you just need to think about what do you want to detect before you start with the annotation process. Something similar, we wanted to detect bags that for a depalletization task. And it was really important to find the center of these bags, but the center of the bags where there's actually something in it. This little flap on the top shouldn't actually be detected, but some person doing the annotation wasn't aware of this or didn't think about it. So sometimes we had the case on the top, sometimes we had the case on the bottom, and the final result just wasn't satisfactory for the customer. So once again, we had to tell him, take a look at your data set, because we know that this should work. There shouldn't be these artifacts you're describing, you're seeing. And after the data set was fixed, the model worked perfectly and the customer is very happy with the application. And one final thing you want to mind that I also have mentioned before, you only should annotate objects you actually want to detect, which in most cases are the objects you can interact with. If we would be gripping this bag, it is underneath the one below it. So if you grip it, it might be that the one below it just falls from the stack it's currently on. If you work with lighter objects like the syringes, they actually can fly through your production line. To avoid any of these issues, just be mindful what objects you're annotating, what do you want to detect, with what objects can you interact. This is basically what's important about this process. And these are just some issues we are frequently running into, and where we have created some guidelines that are also available on the ctrlX website for the AI object matching app, I think. So all the documentation is online. What is the performance and the timing of taking images and running inferences on these images? The performance is influenced just by what hardware is used for the ctrlX core. For the different ctrlX core versions, there are different CPUs. There are optional TPUs available, and I think GPUs are also planned to be coming sometime or be supported sometime in the future. For now, I can just say running an object detection model without a Halo chip or without a GPU is just not feasible. We are in the tens of seconds there. So for now, I'll only focus on the TPU runtime because we don't have a model with a GPU yet. Also the camera resolution, as mentioned previously, we'll learn more about this in a minute. And there's kind of a hard limit for how fast this process can be, just by the need to read and write images to the data layer. Images kind of big for this data layer purposes, so this also takes some time. Capturing images for the X3 model, 1 megapixel image takes about 28 milliseconds. A 5 megapixel image takes about 85 milliseconds. On the X7, we are faster. For 1 megapixel image, it takes 23 milliseconds. For a 5 megapixel image, it takes 55 milliseconds. More interestingly, the inference times. And this is only for a 567 by 432 image. This might sound a little bit odd, but it was just a model that we had around. And this is also kind of the maximum size we can run on a Halo 8 chip. So if we want to work with any larger images, we'd need to run inference on individual patches of the image we want to run the inference on. So, for example, a 1000 by 500 pixel image would just have double the times that we are seeing right now. And the final result is on the ctrlX Core X3, it takes around 730 milliseconds. And on the X7, it takes around 230 milliseconds. So we're really seeing the advantages of the faster processor there, because the Halo chip is the same for both models. About hardware and software selection. So we are a vision company, of course. We have a lot of expertise helping customers to select ideal cameras, ideal lenses, and ideal illuminations for the scene they're working with, the objects they're working with, maybe also the environment they're working with. For example, it can be distracting or unwanted to have a flashing light in a production line where there are people walking around. So it might make more sense to have a light source that's constantly on. On the other hand, if you have a fast moving object, it might be necessary that you need use a flashing light, because otherwise you can't capture this object in time. For the camera, it's just a consideration: what resolution do you use? Maybe do you need some certifications about dirt or humidity? And the camera lens is also important to have the right field of view to be able to work with or to mitigate any distortions a lens might cause. And this is just something that HC Vision Systems can help you with and provide the correct hardware for you. The apps we've just talked about are available on the ctrlX App Store. The only thing to note here is the Windows-based application, that is the LumiScan training framework and LumiScan annotation framework, require a separate dongle because we have additional encryption built into them. And for more general configuration support, there are templates available on the Bosch Rexroth configurator, which I've linked in my presentation. Here is a small overview over the pricing. Once again, the differentiation between apps that run on the EPC and apps that run on a production line, where you still should keep in mind that if you have an integration partner, this integration partner can have one central machine with the training framework and annotation framework on it, where people can remotely access, and there's no limit to how many models can be trained with just one license. But you should still remember that the licenses have an annual subscription fee. So what use cases have we realized with these apps? The first one I want to talk about is a use case where we pick salmon from a conveyor belt. Here we also have the advantage from the orientation that we are detecting. So we can say on this packaging, where's the top, where's the bottom, and how should it be placed in its packaging. And we can also do the differentiation with just one model between the top of the salmon and the bottom of the salmon. And in the production or during the line, it looks like this, where we are orienting the fish in the correct way. We separate the boxes that are visible, lying on their top or lying on the bottom. The ones that are the upside down will just be flipped and be pushed back onto this conveyor belt. And for performance numbers, they required, I think, 900 picks per minute. We created a system capable of doing at least 1200 picks per minute. And from our perspective, it was really just an issue that the robot wasn't fast enough and couldn't do any more reels, any more picks. A second application that we are currently working on with Bosch is a brush cutting cell. And what's being detected here is the middle of two bundles of brushes. So you don't want to cut just anywhere in this brush, but you want to have a fixed point in between these bundles. Sadly, I don't have any real images yet because the project isn't that far apart. We are not there yet, but it's just a real simple application where we detect those spaces in between and then tell the machine you can cut there. This is from a demo in Ulm. I think it's the factory of the future. And we are detecting razors and also differentiating between the different colors of these razors. And we are also detecting the markers of the boxes the razors are in. And these markers are used for a 3D calibration so that we can interact with these razors. And the razors themselves are just there. And a final example for these pick and place applications is also a demonstration we are setting up with Bosch Rexroth. We want to detect those little cups. And in this case, also the orientation is important. We define the orientation just by the orientation of the writing on the box cup. Still very similar use case, but just so that you have an overview of what's possible with the system. It's not always necessary to have a pick and place application. You also can discard the part where we transform image coordinates to real world coordinates or robot coordinates. An example for this would be a quality inspection task. Here we are seeing synchro rings. They are part of a Getriebe. I have forgotten the English word. What's important is the manufacturer wanted us to check if all of these nudges are there, and also a separate check if they are bent the wrong way. So here we can see two of the nudges are correctly there, and this one's bent. So we detect, or we can count, is everything there? And we can also detect something doesn't look right. So this would be an not okay part. There hasn't been some strict requirement for what a bent nudge would look like. So what we did in this case was we just talked to the quality experts of the production line and asked them to provide us some not okay parts to annotate them. And this just, or even with this rather lax requirement, we could successfully train a model that now runs in this production line and everyone's happy. So now that we've seen some use cases, what markets do we have in mind? The first one would just be handling. For example, in machine tending, you want to insert screws into screw holes. In automated assembly, you want to place electronic components on PCBs. We have seen lots of bin picking and placing ideas right now, also depalletization. For sorting, you could, for example, use the quality inspection aspect and remove defective products from a conveyor belt. But also in assembly, for example, in machine tending, you want to ultrasonic weld two plastic parts together and just want a vision systems to make sure everything is in the right position. For quality inspection, we have seen quality inspection. For documentation, maybe you just want to take pictures of the individual production steps, or you want to take a picture of the final product and then save it for a digital log. In food and packaging, we can imagine quality control tasks that check if labels are straight, if labels are present. And of course, once again, we're at bin picking and placing solutions like we've seen with the salmon use case. In warehouse and logistics, the obvious pick and place solutions are picking boxes from some storage bin or picking items from storage bin for order fulfillment. Documentation would then be cases where you take an image of a fully packaged box and really want to document everything is in there. We have done what we promised you to do. And the final application we've been thinking about is fast-moving consumer goods. Also picking, placing application, maybe you want to separate apples and pears in a mixed package and pack them into their individual shipping cartons. Or you want to do quality control on really fast-moving production lines. I've chosen the example of you check toothpaste tubes if they are properly sealed. So this is what we're able to do right now. Since we're a small company, we want to provide you with an outlook with what ideas we have for future apps and for future features. This means that usually we require some projects that cause us to produce or develop these new apps. It's just not feasible to do them without any reason. But something that we'd really like to introduce to the ctrlX ecosystem is just a basic code reader that can read QR codes, that can see CDMCs or read barcodes. I think the application there is pretty clear. Something more interesting would be an image segmentation model. So we've talked a lot about object detection. Image segmentation takes this one step further, and instead of detecting objects, it tells for the individual pixels of an image what class is beneath or is visible in these pixels. So here in yellow, we see a building. In pink, we see a road. The red indicates some kind of vehicle. In green, we have a tree, and blue is the sky. This can be seen as an alternative to object detection. It's not really the exactly same use case. Object detection allowed us for a simple shot saying the object is there, the orientation is this, you don't need any post-processing or something alike. With this image segmentation tasks, we have some other use cases in mind. For example, in quality control, you can indicate really fine scratches or dents in objects that are hard to quantify as objects in object detection. In machine tending, for example, you could train a model that tells you if there's some kind of debris or unwanted object in a loading area. And a use case that's definitely not possible with simple object detection would be handling of deformable objects. For example, if you have some kind of cable or a hose that you want to interact with, this image segmentation approach can really tell you the object's there and you can grip it like this. And a final app we'd like to develop is a generic shape detection app. Unlike with what we've seen so far, this could just tell you there's a circle in this image, there's a box in this image. This would be an app where no training is required. It's mostly important that the objects you want to detect are clearly visible and have a high contrast. But once this can be realized, this would be a lightweight and fast approach to detect circles, boxes, ellipses in images. Of course, if you want to go further, then if maybe the contrast is not high enough, if your objects are more complexly shaped than just circles and rectangles or squares, then you need to go back to the object detection. Also, if you want to detect orientation, you're back at the object detection app. But for these really simple tasks, for example, is a box you have just folded correctly, or you're back at the screw holes, you want to identify screw holes on some kind of metal part, you can just say detect a circle in this area. And also for pill packaging, we've recently had a request if we can place pills in some kind of holes so that they can be filled with some sort of powder. This would be really easy with an app like this and would require no training, no previously seen training data, and so on. So these are our ideas for the future. If you have any use cases you can think of, either for what we're currently or what we might be able to currently realize, or what we can realize in the future with the apps I just showed you, feel free to contact us.